Okay, so today we get to go over what is called instantaneous rate of change. And we get to go over velocity. And the reason for that is because we understand how to find derivatives now using a chain rule or a product rule or quotient rule, sum and difference rule. And we know the definition of the derivative. And we use this in order to answer problems that deal with velocity or instantaneous rate of change. So in the do now, you had to copy some things. I hope that you are already copying some of the other things that are listed here. And it's important that we see this line in the middle. We're going to come back to why there's a line there. So in the do now, we interpret the displacement of an object from its position S as the change of S. And that is basically just the numerator of our difference quotient in terms of t. And so this is it. This is the displacement, change of x. So if you didn't get that down, you do see it again over here. And we interpret the average rate of change of a function over an interval from x to x plus h to be the difference quotient, which we have reviewed when we looked at the graph of a function and between 2 points, x, and this would be the change of x, which we'll use an h to represent that. So to find the average rate of change is the change of the y values over the change of the x values, which becomes really just the h here. And so it's just that difference quotient that we see here, okay? So it's important for you to understand that the wording is different. And if the wording is different, that means that you have to do different things. So again, if you're asked for the displacement, you're just finding the difference between your y values. It's just a change of s. And if you're asked for the average rate of change, you just need your difference quotient. But if they ask for the instantaneous rate of change, that means that it's at a particular point. It's not between two. So if it's at a particular point, it's basically asking for the slope of the tangent, which means we need our derivative. Okay? And so an instantaneous rate of change, or just plain old rate of change at a point, okay, we need to take the derivative, first derivative. Okay, so average rate of change is just the difference quotient, change of y over change of x. Instantaneous rate of change, or just plain rate of change, you need to do the first derivative, okay, either by rules or with our limits. Now, if it asks for you to do the average velocity, okay, the average velocity, that means that you're back to doing looking at your difference quotient. And the reason for this is because we just need the change of s over the change of t, okay? So once again, average rate of change, we need the difference quotient. Average velocity, we need the difference quotient. Okay, that's because it's the displacement over your travel time. That's it. All right, I keep repeating this so that you get it. Average rate of change and average velocity, we need the difference quotient. Displacement, we only need the numerator. And instantaneous rate of change, or rate of change. We're not saying the word average, we need the first derivative. Okay, so where else do we need the first derivative? Okay, so if you see instantaneous velocity, okay, or just plain old velocity, that's where we need our first derivative, okay, either by using the rules, okay, or using our definition or alternate definition of derivative. So you need derivatives if it says instantaneous velocity or plain old velocity, instantaneous rate of change. I'm abbreviating a lot, I apologize. Or just rate of change. Okay, those are where you need your first derivative. If it says average, either as average velocity or average rate of change, that's just your difference quotient. And if they say displacement, it's just the change of s. It's the numerator of your difference quotient. So again, I keep repeating it so that you kind of memorize it. Another important thing with memorizing, you need to memorize this, so make sure you write this down. Velocity tells you how fast an object is moving and in what direction. So the sign of your answer is very important, okay? It'll tell you whether you're moving to the right or left, positive or negative, respectively, would be the signs that you're looking at. The other special note, we're going to put this in red, is the speed is the absolute value of your velocity, okay? So that's very important. That only turns out to be a positive value because it's not telling you the direction, okay? And so if that's the case, you're indicating speed to be the absolute value of your velocity function, okay? That comes into play even later on, so this is something you really need to remember. So I'm going to box this off, make sure that you have it, and let's look at some example problems. Okay, so again, if you need to stop to write down the problems, please do that. Okay, so we're going to do the examples together, and again, stop if you need to. 1A, find the rate of change of the area of the circle with respect to its radius r. Okay, so if it says rate of change, as it says here, that means we're looking for the derivative of the area, okay, with respect to its radius r. So in part A, we need to find the derivative of the area of a circle with respect to the radius r. Okay, so let's talk about area of a circle. Area is pi r squared. So if we take the derivative on the left side of the equation, we get what we're looking for, but we have to take the derivative on the right side of the equation. So it's already going to be in respect to its radius. So if I do the power rule here, I'm going to end up with 2 pi r to the first power. So this is actually our answer. dA over dr is 2 pi r. The derivative of the area with respect to its radius is 2 pi r. Part B, evaluate the rate of change of A at r equals 5. So this is giving us at an instant when the radius is 5. So B is really asking this. The radius is 5. So we're going to take the 2 pi r and plug in 5, and we're getting 10 pi. Please leave it in terms of pi unless it tells you something different. All right, C. If r is measured in inches and a is measured in square inches, what units would be appropriate for dA over dr? This is the derivative of the area with respect to its radius. That's what that's saying. But now we kind of have what is being described here. When we have a fraction line, that means the word per. So if they tell us that it's in square inches for the area and the radius is in inches, that means that our final answer here is your units would be in square inches per inch. Okay, that's how we would write out its units. All right, we're up to number 2. So in number 2, the number of gallons of water in a tank t minutes after the tank has started to drain is given by the function Q of t. A, how fast is the water running out at the end of 10 minutes? Okay, so unlike the last word problem where they asked for the derivative of area with respect to its radius, or evaluate, so that means that we get a number, or to just write the units, it's a very simple thing. But now here we actually have to answer a question, and when we do that, there's a way in which we have to write our answer, so I'm going to go over that. The first thing is to notice that it says how fast is the water running out at 10 minutes. So this is instantaneous velocity. So that means that we need to figure out what Q of t is, so we can apply the power rule and then get Q prime of t. So let's do one thing at a time here. So Q of t is 200 times, it's going to turn out to be 900 minus 60t plus t squared. Okay? And so at this point, I could distribute the 200. And the reason we're doing this is because we don't know any other rules but our power rule, our sum rule, a difference rule. And yes, we do know product. If you want, you can do the product rule here. And we know quotient rule, but that's not helping when we have a quantity to some power. So we're going to get to that rule in a future lesson. So right now we're just going to go with our simple basic skills here. We know how to multiply and distribute. And this is what we get for Q of t. So now Q prime of t, okay, don't plug in first. Remember from the last lesson, plug in last. So I'm using the sum and difference rule in conjunction with the power rule. And this is what I get for Q prime of t. Now I get to plug in 10 for t, okay, because we want to know what happens at 10 minutes, okay, how fast it's going. And this is going to come out to negative 8,000, and it would be in gallons per, you can use that line to mean per minute. Okay, period. Well, kind of not period. Let me go over how to write our answer. Okay, so we want to say that the water is running out. And I'm underlining out only to also underline that's the fact that we got a negative answer at the rate of, and we're just going to use the 8,000 because we already indicated the negative sign by writing the word out. It was in gallons per minute, I'm abbreviating here, at t is equal to 10 minutes. Okay, it's important to have the units and to have at what particular value. Okay, so we're kind of answering that full question here. And we're up to part B. So B asks, what is the average rate at which the water flows out during the first 10 minutes? So remember, when it has the word average in it, you're actually just needing the difference quotient, okay? In the first 10 minutes, that means that's when t equals 0 to when t equals 10, okay? So if I'm doing the difference quotient here, I'm doing Q of 30 minus 10, okay, from this part here, squared, minus, and I can put this in parentheses, 200 minus 30 minus 0. Remember, substitution is very powerful. Make sure that you have it, because that comes from here. over the 10 minus 0. Okay, so this is showing that you did do the change of time. You're just not taking the 10 and plugging it in. And you plugged in 10 and 0 into our numerator. So at this point, we can figure out that we get 80,000 minus 180,000 over 10. So we get negative 10,000 as our final answer. So what this means to answer the question, okay, is that the water is flowing out. Okay, and again, out is because of the negative sign we have here. Otherwise, use the word in. At an average rate of 10,000, that's supposed to be a comma, gallons per minute over the first 10 minutes. Okay? And that's answering part B. Okay? So that's it. Good luck.